The sun. It's not much, but it's ours. Today we're going to talk a little bit about the sun and some of its features.
Galileo and Englishman Thomas Harriot both observed the sun and sunspots in 1610, but they weren't the first. Chinese and Korean astronomers wrote about sunspots almost 3,000 years ago. John of Worcester, who was an English monk, made the earliest existing drawings of sunspots in 1128. Galileo's solar observations of 1612 were made at the same time of the day every day, and so the motion of the spots across the sun can easily be seen. This motion allowed early astronomers to estimate the sun's rotation period, which is about 27 days. The early astronomers soon projected the sun's image through the telescope onto a piece of paper or through a pinhole projector. This made it possible to study the sun in detail without damaging their eyes. Many other astronomers in the 17th century, including Scheiner, Gassendi, and Hevelius, also recorded their solar observations. More than 24 past and present NASA missions explored the Sun-Earth system. The Ulysses spacecraft, which launched in 1990, studied the sun before, during, and after the last solar maximum in 2001. After more than 18 years in flight, Ulysses returned a wealth of data that led to a much broader understanding of the global structure of the sun's environment. The TRACE spacecraft launched in 1998, and it studies the magnetic structures which emerge through the photosphere, or the visible surface of the sun. The Genesis spacecraft collected samples of the solar wind, a stream of charged particles from the sun. The samples were returned to Earth in 2004 and are now being studied in a special lab at NASA's Johnson Space Center. Stereo, which launched in 2006, uses two observatories, one ahead of the Earth in its orbit and one behind, to study the structure and evolution of solar storms as they blast from the sun and move out through space. SOHO, the Solar and Heliospheric Observatory, has been keeping a watch on the sun since 1996. It can warn the Earth of approaching coronal mass ejections that could disrupt communications.
So, what is the sun? Well, the sun is a star. It's actually a pretty average-sized star. There's a lot of stars that are bigger and a lot that are smaller than our sun. It's very average in its size and also in its stage in its life. It only happens to be so bright for us, brighter than the other stars in the sky because it's so close to us. It consists entirely of gas. There is no solid surface, and it's mostly hydrogen and helium, the lighter elements. And without the sun, we know that there would be no life on the Earth. Well, the sun is also hot. It's very, very hot. And that heat helps life to be possible on the Earth. And that heat comes from fusion deep inside the core. Here the temperature is more than 15 million Kelvin, so it's very, very hot. And every second, 600 million tons of hydrogen are being converted into helium. And through that process of fusion, lots of heat and energy are given off. And you can see here in this little picture that hydrogen combined to form helium, and then it travels outward from the sun and brings lots of energy and heat towards the Earth. Now we're going to take a look at a brain pop.
Dear Tim and Moby, why is the sun so hot? From Arthur P. The sun is actually a star, the closest one to Earth. It looks so small because it's about 150 million kilometers away, but it's actually 1,000,000 times the size of Earth. Even so, we can still feel its immense heat. Well, the sun is way hotter than a stove. The photosphere, or surface of the sun, is close to 6,000 degrees Celsius. And if you went down into the core of the sun, you'd experience temperatures around 14 million degrees Celsius. Right, don't go into the sun. The sun is made of mostly hydrogen and helium. Nuclear fusion reactions caused by the sun's massive gravitational field fuse the sun's hydrogen into helium. This produces enormous amounts of energy, way more than enough to power all life on Earth. Energy from the sun makes plants grow, which animals eat, who are in turn eaten by other animals. The tilt of the Earth causes sunlight to strike it at different angles throughout the year, causing seasons. The sun dictates the seasons, controls the weather, and drives the water cycle. Take away the sun, and the Earth would quickly become a frozen ball of lifeless rock. We're also lucky that the Earth is just the right distance from the Sun. A little closer, and all of our life-sustaining water would boil away into space. A little further, and it would all freeze solid. The Sun was created out of the same cloud of gas and dust that formed the rest of the solar system. This cloud probably came from an old star that exploded at the end of its life, as stars sometimes do. Today, the Sun contains 99.8% of the mass of the solar system. That's almost everything. And in case you were wondering, the Sun is middle-aged. It's about 4.5 billion years old, and it's got another 4 to 5 billion years to go. At the end of its life, the Sun will expand into a red giant, reaching out all the way to where Earth is now, and then throwing off its outer layers as a planetary nebula. Well, these days, the Sun is a very active place. Enormous jets of burning gas called prominences and strange dark patches called sunspots are caused by the Sun's gigantic electromagnetic field. Sunspots, as well as other solar activity, seem to follow an 11-year cycle. The Sun's atmosphere, or corona, can be seen during an eclipse. Which reminds me, don't ever look directly at the Sun. Powerful solar radiation can blind you for good, and no one wants that. Likewise, you should wear sunblock when you go outside for long periods. The ultraviolet radiation that the Sun gives off can cause permanent damage to your skin. So respect the Sun. Love the Sun. You don't have to take care of the Sun. It does fine on its own.
So here we have a picture of the Sun and some of the different solar features that we see. And now we're going to take a look at the different layers or zones of the Sun. The core is the innermost layer of the Sun, and it is a source for all the Sun's energy. The material in the core has a very high temperature, which is about 15 million degrees Kelvin. Thermonuclear reactions take place inside the core, where hydrogen atoms are combined with each other to make helium atoms and produce energy. This thermonuclear reaction is called nuclear fusion. Once the energy is produced in the core of the Sun, it has to travel from the solar center to the outer regions. The radiation zone provides an efficient means of transferring energy from the core. The temperature in the radiation zone of the Sun is cooler than the core itself. Thermal convection occurs as thermal columns carry hot material from the radiation zone to the surface of the Sun. As soon as the material cools off at the surface, it plunges back down towards the bottom of the convection zone. So in the convection zone, we constantly have columns of rising gas, and then as it cools off, it sinks again, and that's what convection is. The photosphere is the visible surface of the Sun. So that is the outer layer where we see sunspots and solar flares and many of the different features that we're going to learn next. The chromosphere is a thin layer present above the visible surface, which is about 2,000 kilometers thick. The corona is the outer atmosphere of the Sun, which is much larger in volume than the actual Sun itself. So you can imagine how far outward it extends. And you can see here in the picture that kind of the outward whitish part that extends beyond the Sun, that is the corona. This layer of the Sun is only seen during a solar eclipse. The Sun's magnetic field is responsible for most of the features that we see on the Sun. What happens on the surface is that the plasma, which is a state of matter even hotter and moving faster than a gas. So we have moving plasma on the surface of the Sun, and this moving plasma produces magnetic fields. And it's the interaction of these magnetic fields with each other that produce many of the different features that we see. And as you see here in the picture, we have a looping arch of gas right here. And so what we have is a north pole and a south pole right next to each other on the surface of the Sun. And we see those all over the surface. The features that we're going to talk about are sunspots, prominences, solar flares, and solar wind. Sunspots are cooler regions of the photosphere, and you can see them here with these dark colors. Now they only appear dark against the bright sun, but they still would be brighter than the full moon if we took a sunspot and placed it in the sky. They're actually very, very bright. They just appear dark because they're cooler than the area around it. Sunspots are caused by intense magnetic fields which slow down the flow of heat from the Sun's interior. We talked about the radiative zone bringing up heat into the convection zone, which in the convection zone we have rising columns of gas that cool off and then sink. Well, the magnetic fields in the photosphere sometimes stop that rising that plasma from rising all the way up, and they block that. And so when that rising plasma is blocked, then it appears a little bit cooler, and it's these intense magnetic fields that slow down that flow of heat. And here's a picture of some different features, kind of that same magnetic field that I showed you before. And at each end of the magnetic field, at each end of that loop, we often see sunspots there. Sunspots actually follow an 11-year cycle, and this is something we'll be exploring more in class, but we can pay attention to and we can see how many sunspots are on the surface of the sun at any given time, and the sun goes through cycles. There are years when there are lots and lots of sunspots and lots of solar activity, and then there are years when there aren't very many, and this cycles, and it's an 11-year cycle from one maximum to another, and we're about to go into a solar maximum next year in 2013, which you might have heard of and which we'll talk about more in class. A solar flare occurs when magnetic energy that's built up is suddenly released. So often a sunspot will be blocking that plasma from rising up for a long period of time, and after that magnetic energy builds up long enough, sometimes that sunspot will erupt in a solar flare. And you can see in this picture, here's a great solar flare rising from the sun, and you can see it shows the size of the Earth, so you can see how really big these solar flares actually are. And here is a great visual of an actual solar flare, and you can see that the sun itself is blocked out by a disk there, and that's so that we can see the corona of the sun, that outer atmosphere, and we can see that solar flare a little bit better. And you can see it's kind of replaying it a few times here. So let's see it one more time. And we can see how it kind of bursts forth, and there's several different ones there for us to take a look at, and so these are really nice. And those are all different solar flares that we're seeing. And then this area all around the sun that extends much farther than the sun itself, that is the corona. A prominence is when gas is ejected from the photosphere and then it comes back towards the surface of the sun. So in this picture here you can see these looping arches of gas. That's what a prominence is. And it often goes from one sunspot to another, and it goes from a northern magnetic field to a south magnetic field. Solar wind is a stream of charged particles, and these stream off the sun in all directions at any given time. But the strength of the solar wind can vary, often with the solar activity. So when we're in a solar maximum, we get a lot more solar wind, and when there's a solar minimum, there's a lot less. They travel at about 1 million miles per hour, so they're very, very fast, and they can produce aurora borealis when they interact with the Earth's ionosphere. The charged particles in the Earth's ionosphere, when the solar wind hits them, they can cause the aurora here. So that is it for the sun video. Please make sure you have all of the notes written down that you need to for class and rewatch it if you need to.